Okay, so let's talk a little bit more in depth about our nasal cavity. So, when we talk about the nasal cavity, I mentioned that that is part of your respiratory tract. We want to breathe in using the nose because that is actually a really important part of the respiratory system because it functions to humidify, to which is moisten the air, to warm it, and to filter it. It also is important for smell, right? So the smelling, we'll talk about that function of the nasal cavity in a moment. Okay, so the outermost part of your nose, your nostrils, right, enter into a part of your nose called the vestibule. That is where you can stick your finger, right? This is actually stratified squamous epithelial tissue. So it's many layers of flat cells, just like your skin, right? So it consists of actually dead cells. But there's also in this vestibule, there's sebaceous glands, there's hair follicles, and there are sweat glands. So we have sebaceous glands, which are associated with hair follicles. So we have nose hairs. And then we have sweat glands. Okay. So if you've ever worked in a very dusty environment, you know that you get lots of boogers, right? You get lots of stuff, gunk being caught into your vestibule. And that is actually a good thing because if you were like breathing in through your mouth and not using your nose, right, you would actually possibly get that dust into your lungs, and so that would be a bad thing. So that is actually good when you're working in a dusty area to make sure that you're breathing through your nose, right? And then it goes actually into the nasal cavity. So the nasal cavity is separated by the septum, right? And that nasal septum is actually important. Sometimes it causes a problem and you have to have surgery on your nasal septum if it's like deviated from where it's supposed to be, right? So this nasal cavity actually is not stratified squamous epithelial tissue. It is pseudo, for the most part, pseudo stratified, ciliated, columnar epithelium. Now, what does that mean? That means that it looks like it's stratified, but it's not. So it is really just a single layer of column shaped cells that have cilia on them. And this is actually what your kind of like what is found in your trachea, but it's also kind of what is found in, like, say that, for example, the stomach and the small intestine. It's columnar epithelial tissue. So what this means is it can be easily damaged. So this is not any place where you would ever stick your finger up. And in fact, if you did, it would probably cause a lot of bleeding. Excuse me. So this part of your nasal cavity would bleed and be damaged very easily. But one of the things that it does have is it has goblet cells. And these produce mucus. Mucus is actually protective. So you remember that mucus forms a barrier. Sometimes mucus, I think it's a European spelling, is spelled M-U-C-O-U-S. So if you see it spelled M-U-C-O-U-S with an O in there, then you know it's the same thing as the regular mucus. Okay, so let's look at a diagram of this. So this is my nostril right here. This is my vestibule. And then up past the vestibule would be where you have that simple columnar. It's pseudo-stratified, but it's columnar. And so you can see that this has a pretty large surface area, and that it also has these weird invaginations. And these are actually referred to as nasal conchae. So the nasal conchae, let me get our conchae, to pronounce both. The nasal conchae. Okay. These are like, what they do is they increase the surface area, and they are kind of shaped in a way, they're like these protrusions, and they actually cause turbulent airflow. So when you breathe in, the air doesn't just go straight to the back of your throat. It actually hits these conchae or conchae, and it actually moves around in kind of a weird pattern, right? And so what this does is this increases the filtering activity. So it increases filtering, right? So stuff will fall out of the air, right? So if we look at that, we can see that even in the cadaver, like you can see all that surface area, right? This also, as air goes over it, is going to moisten. So it's going to moisten the air. It's going to warm the air. You can see the hair inside the nasal cavity of our cadaver. We can also see from this diagram that the nasal cavity and the oral cavity are separated by the palate. So this palate bone is important. Not all organisms have this. Like frogs, their nostrils just enter right into their oral cavity. So they actually have no nasal cavity, right? They actually, it's very different structures than us. So we have our nasal cavity and our oral cavity separated. Reptiles do too. So like lizards and snakes. And what this means is that we can, in mammals, we can chew our food and breathe at the same time. So I can chew and breathe, and I could chew and spend a lot of time chewing so that my digestive system is super efficient. And then I might hold my breath as I swallow, right? So part of the nasal cavity also has a different type of membrane. And this is what I call, or we call, the olfactory epithelium. So here we have my olfactory epithelium. And we talk more about this when we talk about the sensory system, because we have these olfactory neurons that dangle their little appendages, their cytoplasmic extensions, into our nasal cavity. And it is the binding of chemicals to these neurons that generates an action potential that then travels up and into your brain via these little tiny holes. These go straight into the brain, right? You might have heard of this problem. There's actually a problem with this. Like, say, for example, you might have heard of people getting amoebas in their brains because they had gotten bad water, like pond water. This is very rare, but sometimes it happens. So let's say I'm swimming in a pond and I snort in some water accidentally, and there just happens to be some of these amoebas that are single-celled organisms that then crawl up my neurons that are dangling down into my nose, and then they get into your brain, right? And they cause great amount of damage, and they can actually lead to death. So those brain-eating amoebas that get into your brain via your nose, that's the path that they travel. Crazy, huh? Okay, so odorants in the air bind to those receptors, and that is what gives us the sensation of smell. Now you'll notice that this then empties in to the nasopharynx, right? The nasopharynx is right there. And so sometimes when we drink stuff and we cough or we laugh, stuff comes out the nose, right? Or unfortunately, if we vomit, sometimes stuff goes out your nose. So that is why the reason for this is it's connected to the back of your throat where you swallow food. So things can go up the wrong way, and that does not feel good, right? And so that becomes an issue as well. Okay, so that is your nasal cavity.